Welcome to the Hidden Brook Technologies presentation on circuit rhetoric. You're probably asking yourself, what exactly do I mean by circuit rhetoric? Well, the term has its origin back in the Middle Ages, when medieval Europeans invented the university system. They went and divided every discipline into three strata: that of grammar, dialectic, and rhetoric. Dialectic is also known as logic. The grammar is the fundamental building blocks, the toolkits of a given discipline. Dialectic is assembling those building blocks and causing them to function by design. And the rhetoric is how well the end result brings about the desired effect or impact in accordance with both natural and human laws of aesthetics. So we can apply this to language arts. We see that the building blocks, the grammar, it's letters, words, word classification, such as noun, verb, and so on, sentence structure, what have you. The dialectic element of language consists of assembling these building blocks in a correct and meaningful fashion. Sentences and paragraphs that are not only grammatically correct, but also logically or factually correct, conveying coherent meaning. And on top of both of these, does the language speak to the heart and the soul? Does it resonate in the mind and the imagination? Does it express mastery and deep understanding of the subject? Per Aristotle, does it persuade? This is the element of rhetoric. Well, we can apply this same trivium model to many disciplines. Let's take athletics, for example. The grammar of a sport or a game consists of the playing field, the equipment, the rules of the game. The dialectic is how these elements coherently interact, how to execute the pass, how to find the sweet spot in a bat or a racket. The rhetoric involves an elegant playing style or strategy. Is this team a well-oiled machine that functions as a unit, swiftly outmaneuvering a disjoint competitor? Does a player achieve victory by applying power with elegance and efficiency, or by merely applying power only as brute force to overwhelm an opponent? Is this landing poetry in motion that exemplifies the grace and beauty of the human form, or does it remind us of a drunk trying not to fall down the stairs? And what about sportsmanship? Is the player gracious, or does he insist on making a spectacle of himself after either success or failure? And so, in engineering and design disciplines, you can take an aqueduct, an amphitheater, a cathedral. Besides being functional, the rhetoric of these buildings speaks to us. It lets us know what their purposes are, why they exist at all. And in some cases, the rhetoric tells you why it should never have existed in the first place. Given these two venues, which one would you rather dine at? The gladius, katana, recurve bow, these are all designed for the organizational and fighting styles of the men that used them. Fighting as one of the Khan's horse archers, or as a samurai for your daimyo, or as a member of a Roman legion, these were all very different undertakings. And these weapons, besides being grammatically and logically correct for their intended uses, were also expressions of the environments and the peoples that created them. They were works of art. The Flying Cloud, USS Constitution, HMS Victory, these are all fine examples of their respective functions, as well as clean expressions of those functions. While it's possible to fault the clippers for having too much sail for their hull size, being too narrowly proportioned, well, that's what happens when you optimize to the extreme for one variable, in this case, speed. But it is still a beautiful thing to behold in any case. Isambard Kingdom Brunel. He was the engineer's engineer of the 19th century. He masterminded railroads, transatlantic companies, and the machines that traversed them. His Great Western Railroad used Sir Daniel Gooch's Firefly and Iron Duke locomotives. In this early locomotive type, all the grammar and the logic for the age of steam were in place. While the architectures that employed those two large, beautiful drive wheels had some balance issues, they were corrected only by moving to architectures with 4 or more drive wheels. Well, the rhetorical grace of this class of locomotives just can't be argued with. If they were good enough for the Queen Empress, they are certainly good enough for us. Now, the ocean liners of the early 20th century were rhetorically beautiful embodiments of Edwardian luxury, and none more so than RMS Titanic. But we all know the story. Its underlying grammar and dialectic were flawed. An undersized rudder, brittle iron rivets, inadequate bulkhead design, all of these led to maritime infamy. Now take a look at these beauties. Just one look at the lines of the Hughes H1 or the XF11, and you can see the master rhetorician at work. The H1 was a racer that held a speed record for a time, and the XF11 might have been the fastest reconnaissance aircraft of its day, were it not for an oil leak that caused an in-flight failure while Hughes was making a test run over LA. He was critically injured in the resulting crash, and the disfigurement he sustained was why he, in fact, wore that mustache from then on to cover it up. And overcome by events, the XF11 design never went into production. Well, after that little tour through engineering history, we'll see that we can adhere to that model of the trivium for our far less glamorous pursuit of circuit design. In our case, our grammar is voltage, current, resistors, capacitors, semiconductors, Ohm's law, Thevenin equivalence, and so on. Our dialectic, is it a design that meets requirements, functions as intended, and does so across a wide range of input and operating conditions? How about flexibility, scalability, reusability, if possible, and if warranted? DFM, DFA, EMC considerations, these all have to be incorporated and baked in from the beginning, not, attempted as afterthoughts. And now the rhetoric. How well does the schematic diagram convey the intended function of any portion of the design? Are there diagnostic indicators or test points on the board that allow rapid assessment of function and status? Is everything of interest clearly marked? How well does the finished board convey the purpose of the connectors and status indicators to an assembler, to a tester, or to another engineer? And do the ergonomics make assembly or use intuitive? I had this schematic handed to me once to take a look at, and this is emblematic of the poor rhetorical presentation that is typical in the electronics industry. A cursory inspection of this, you can find out that these circuits are DC motor controllers, each driving an H-bridge MOSFET. But closer inspection really bogs us down. So what's the purpose of any particular passive component that we're examining? It's difficult to tell. It's really tedious to trace these connections, and it's impossible to remember what we've covered and what we haven't as we review this. Here, however, is a similar circuit, which is only one driver and one MOSFET bridge. Now, this is an example of a much clearer presentation. The signal flow is readily apparent. In this case, it progresses from left to right. Since this is how readers of Latin-based languages tend to process information, it's best to adhere to that convention when possible. Now the whole page begins with the schematic symbol for the IC, and that was created with the page layout already in mind. The logic inputs are on the left, the FET gate drivers are on the right. Power is at the top, ground, and the configurations that need that ground, they're at the bottom. The symbol is also made sufficiently large, and its I/O pins are located and they're spread out to allow placement of the surrounding passive components in a clear and meaningful fashion. Pull-ups go up, pull-downs and the bypasses go down. The high current paths through the H-bridge and then off the page are readily apparent. The gate control paths are easily traced, and the function of the associated passives is readily understood. Symmetry in the signal path is applied where appropriate, and this is in keeping with the human mind's ability for pattern recognition. The irrelevant component parameters are all visible. Net names liberally applied. And this is primarily to make the layout process that much easier and more efficient, but it also serves to make the schematic that much more informative. And notes have been added here and there to bring forth further insight. Now, while this approach requires more pages to contain a given design, using more pages actually makes the design easier to understand when compared to an overcrowded schematic that tries to cram as many functions, often unrelated ones, into as few pages as possible. So this page we're looking at can be replicated as many times as necessary for a design with multiple motor controllers. That will allow someone who's browsing through the design to grasp what it's about without getting distracted by so much clutter. Now, we can apply Rhetoric to layout, and it has the same objective as it does in the schematic. Namely, that is clarity in presentation. And we can see that this layout exhibits it. The connectors have been labeled with their reference designators. They all have pin 1 called out somehow. And the ref-des is as close to pin 1 as is practicable. The connector functions are also indicated in the printed text. The ICs are labeled because these serve as important markers for what function is occurring where on the board. Test points are labeled. In the case of the power supply test points, there's also an LED indicator right next to them. It shares the label with it. That gives you at a glance, is my basic function up and running. This layout also exhibits good clarity in its presentation. The transistors are labeled since, like ICs, they serve as important locators within a design. The large header has the test points for both pins 1 and 2 labeled to remove any ambiguity concerning the pin numbering pattern. In addition, tick marks are shown on the test points for pins 5, 10, 15, 20, etc. to aid in the debug. And besides good rhetoric, this design also exhibits good dialectic. Note that in spite of no door sensor cable being attached, the door status indicator still indicates secure. Well, in this system, that was unavoidable, given the photo interrupter type and the electronics necessary to interface to it. However, this design also includes a present indicator. Since present is not indicated, the supervisory electronics can know that this secure is in fact a false positive. So the what-if situation of a missing sensor has been covered in the design, and that is good dialectic. Now in this case, this circuit was designed entirely for the sake of beauty. And still, in order for it to work, the grammar and the dialectic have to be correct. But the entire purpose of this was a rhetorical expression. And this happens to be the Hiddenbrook Tech Timepiece 101. Well, thank you for watching. And for help with your latest project, don't hesitate to contact Hiddenbrook Technologies.